Hello everybody and welcome to the Microsoft Data and AI South Florida user group. My name is Adriano and I'm your host. And today we'll be talking about reduce Azure SQL costs by optimizing your query workload by Torsten Strauss. And before we get started, let's talk about the questions. So if you have any questions, you want to interact with other attendees, please use the live chat, which you can access by being a subscriber to the user group, as you can interact with us in real time during this live presentation. If you are watching us after on an on-demand basis, please use the comment section below the video to enter your questions as well as your location. So, without further ado, and I bring you Torsten Strauss. Hello, Torsten. How are you?
Hey, I'm fine. I hope you can hear me.
Yes, I can.
Okay, perfect. Yeah, I'm fine. Thanks a lot for giving me the opportunity to speak about mainly query optimizer and reducing costs. Yeah. For sure, also perform or tune your workload. That is what I'm going to present here. Yeah. Shall I introduce myself a little bit more?
I'm sorry, Torsten. What did you say?
I'm just asking whether I should introduce myself or is this
Oh,
something
no.
you can... Yeah?
Great. Can you tell us where are you located at?
Yeah, I'm located in Germany, city called Bochum, which is close to Düsseldorf. Maybe most of the people at least know the airport, Düsseldorf. It's a very huge one here in Germany.
All right. And can you tell us a bit about your job and your role?
Yeah, so as you can see, I'm a consultant, I'm a trainer, I'm a speaker, I'm also an employee of the company BP. I also run my own business and I work very closely with a company called Zapedon. And I would say mainly specialized in performance tuning of large SQL Server environments.
Excellent. So it goes right in hand with your presentation. So can you give us just a little short bit about your presentation? And I know you'll talk more about the presentation later, but at least kind of a quick 30-second here for us.
Yeah, so what I'm going to show is, first of all, the query store was introduced, I guess, with SQL Server 2016 or 16. And since then, it is improved over the SQL Server versions. And I guess it is really an amazing tool which gives people a much better insight in the current workload and give people the opportunity to tune queries, to tune their workload in order to reduce the overall, I would say, CPU, memory, I/O consumption, which is definitely worth to do because this gives you the chance to reduce your operating costs, maybe on Azure, on a VM, or a managed instance, or even SQL database.
Awesome. So that sounds very interesting. Definitely will help those who are new and considering using, Azure SQL Database as a service there, as well as those who have been using it, because they may be able to leverage some of the techniques that you're outlining here for us today.
Mm-hmm. Mm-hmm.
All right. So great to hear. So without further ado, Torsten Strauss, folks. It's all you now, Torsten.
Cool. So can you just confirm that you can see the screen?
Yes, I can.
Studio. Perfect. Then I will start. So as mentioned already, Query Store is a fairly new feature because not all of the companies are already running SQL Server 2016, 17, or even 19. So I know that a lot of companies are still operating SQL Server 2012, 14, or whatever. So therefore, I really recommend to upgrade to a newer SQL Server version, because you got a lot of more for the same money. Yeah? And one really amazing feature, as already mentioned, is Query Store. So what is Query Store about? So the Query Store collects query and plan information. So that means you can analyze the workload, as already mentioned. And we will go through the presentation, and I will for sure share some reports. Yeah, we have several reports available, which you can use in order to understand, I would say, which kind of queries are worth to tune. Yeah? So the Query Store is also there to collect runtime statistics. Whenever you execute a query in SQL Server first of all have to create a so-called query execution plan. So that is the first part of the Query Store. We really have two different stores here. So the second one is, after the query execution plan is created, and in most of the cases it is cached, yeah, it is sent to the plan cache, the query is executed, and now the Query Store asynchronously collects runtime statistics. So that means you always have the possibility to go back to Query Store in order to, I don't know, to track a specific query, for example, to see whether your query or your index strategy you might apply was the right one, or even, I would say, have no effect or even have a negative effect. So therefore, I really like the idea of having a Query Store, because as we will see with the traditional approach, query runtime statistics, I don't know, to track kinds of traditional DMVs, it is sometimes really hard, and we will see the difference here. Yeah? So that is, again, the main purpose of having the Query Store. And you can see that there are also, I would say, three functionalities which the Query Store additionally offers. So first of all, you can force a specific query plan for a specific query, which I definitely not recommend. So I have one example later, you will see it, that normally forcing a plan for a specific query is just, I would say, it is not a solution for the root cause. It is more or less just for the time being, until you implement maybe the right index strategy or rewrite your query or whatever. So please do me the favor and do not force specific query plans. So the second one and the third one is about automatic query tuning. So we have two features. One is only available in Azure, which is the automatic index management, but enable automatic plan correction is there since 2017, even on premise, and for sure in Azure VM. And this is a feature which depends on Query Store as well. That means we need to enable the Query Store in order to benefit from the feature. I do not want to judge about the feature in this presentation. I have another presentation on automatic plan corrections. I personally would say it is not bad when you have to manage, I would say, hundreds of SQL servers. Then it is really worth to think about it. Otherwise, when you have a dedicated SQL Server machine, maybe it is better to even disable plan correction, but it is my personal preference here. Okay, so now let's compare the new Query Store with the traditional approach. As already mentioned, the Query Store collects all the information I already mentioned, and there's a big difference to the traditional DMVs. The Query Store, all the information which are collected are written to the primary file group of the database. It is good that SQL Server will persist the data. That means when you restart SQL Server, all the information are still available, which is completely different to DMVs. I have a lot of customers, and I've seen it often, that people tend to restart SQL Server when SQL Server is slow. And afterwards, they try to investigate the root cause of the slow performance, which does not work, because all the DMVs which are kept in memory are completely flushed. So no data are available anymore. So for the query store, you will get all the information. And again, they are written to the primary file group. I personally do not like that Microsoft decided to send all the information to the primary file group. I hope they will change it, that I have a dedicated file group for it. But okay, it is better than the traditional approach for sure. So another difference is that the information are captured on statement level. You know, the traditional DMV are captured on batch level. So for sure there are techniques in order to, how can I put it, to separate the batch, to get the specific statement. But it is a little bit more complicated, I would say. So the other thing is that the query store also captured native, all the information, so about the plan and runtime statistics, also for native compiled stored procedures, which is in memory OLTP, which is also available in the traditional approach, but you have to enable it. So the query store already enabled capturing information about in-memory OLTP per default. So, and that is maybe my favorite one. It is much easier to identify plan regression. And we will talk about plan regression because you have to understand what a plan regression means and what is the consequence of a plan regression. This is definitely very, very hard, very difficult with the traditional DMVs, query runtime statistics. It is almost impossible, I would say. I know that there are workarounds available, but it is far away from easy. So that's it. And another one, which is also worth to mention, is that you can enable the query store, as we will see when it comes to the configuration. We can enable the query store on just one or more specific databases. So when we can disable the query store also without losing all the data. So it gives you a little bit more flexibility, right? You can decide where you want to enable the query store. Because, you know, whenever you enable a feature like query store or other performance tools, it has overhead, as we will see. That means when your database is already running slow because it suffers from resources, CPU, memory, or whatever, and you want to analyze the root cause of the performance problem, and now you enable a tool like query store, you put additional effort, additional resource consumption on top of the database. This is something you have to understand. Nothing is for free. And therefore, it is good that you can decide to enable query store just for a specific database, or you even can decide to pause it. That is definitely a nice feature. Okay, so we have specific reports available, and I hope that the query store is enabled. Yeah. So, and by the way, the folder query store underneath the AdventureWorks 2017 is only available. So this is a folder which is available in every database for sure, but only if you enable the query store. So as far as you create your database, query store is disabled. That means you will not even see the query store folder here. And when you do not see the folder, for sure you also cannot see the, I think, 7 reports. And we will see the reports later in action. But this is the integration from a GUI perspective. That's it. So I'm not a very big fan about using the GUI, the report which is available. Everything which is collected by the query store, you can also use DMVs, which again the data are persisted, but you can use DMVs in order to do more and further detailed analysis than I would say the embedded reports offers. Yeah? That's a difference here. But maybe for most of the performance problems, the reports are already sufficient. Yeah? Okay, Let's talk a little bit about the architecture. And what I will do is I will open one picture which gives you a better understanding about how the query store is set up. Query store. One second, I just need to figure it out. Query store architecture. Here we go. So that's a problem when you have a lot of files in your folder. Okay, that is the current architecture. I guess it is a picture from Microsoft. So you can see again, we have two stores within the query store. We have the plan store, we have the runtime statistics store. So again, when SQL Server first executes the query, it has to create an execution plan. This is the compilation. So, and this is which is always before the actual execution of the query starts, as far as there is no cache, no plan in the plan cache, right? So the information are sent synchronously to the plan store, and this is the in-memory part, as we will see. And then when the query is executed, only after execution, all the runtime statistics are available, like time, like logical IOs, physical IOs, memory consumption, all these kind of things we are really interested in. So this is a runtime statistics part, the store of the query store. And we have an asynchronous write back to, again, to the primary file group because of performance considerations, as we will see. There's something which is called the flush interval. I will talk about this later, which gives you some kind of flexibility here. So the normal or the default flush interval in seconds is 900, which means at maximum. It is not every, but it is at maximum every quarter. The information, the runtime statistics are sent to the query store. I will go more and more into detail and present something, or I have several examples, which gives you a much better insight. But for now, I guess it will already give you, or I hope it already gives you a good understanding about the architecture of the query store. Wonderful. So let me enable the query store. So this is pretty easy. You just have to say alter database current set query store on. There's one pitfall most people do not know, and I didn't know before I prepared for the session. The problem here is, and I have an example later on, that at the moment you enable the query store, all the plans which are currently in the plan cache are flushed. That means your plan cache is empty now. That is something whenever you have a command like alter database, or not all commands, but in general, I would say altering a database, altering the state of the database, in most of the cases, will flush the query store, which is for sure a big problem. That means every new query execution SQL Server have to create a new execution plan, right? Sometimes now the performance problems you had in the past, maybe they are not there anymore because of parameter sniffing, for example. Think about maybe you have a plan in cache which was not optimized for the usual workload, but the first time SQL Server created the execution plan, the stored procedure was called with a not typical parameter. And therefore, this can lead to performance problems. When you now enable the query store in order to figure out what is the root cause of your performance problem, why is this stored procedure running that slow? You flush the stored procedure cache. And maybe the next compilation of the execution plan of the query will generate a complete different execution plan. So therefore, you do not have a chance to see what was going on. So this is something you have to keep in mind. So In general, I would say there are specific settings, as we will see later on, to determine the frequency and the behavior of the frequency of the write back and also the behavior of the query store. So maybe it is worth to enable query store by default when you have the right settings to avoid these kind of problems, right? Because you cannot analyze something which you didn't capture. That is a problem here. Okay, it is enabled now. And you can see that there's one DMV, there are a lot of other DMVs, which is called query store runtime statistics. So we will go into the DMV later, but you can see, and the name already reveals the purpose of the DMV. So query store runtime statistics will give you information about runtime statistics, which means how often the query is executed, the average duration, last duration. We have CPU-related columns. We have logical reads, physical reads. You can see a lot of things. And since 2016, I guess it was the year the version, the first time query store was released, additional information like weight statistics were implemented, right? We will talk about weight statistics later on, because weight statistics is definitely something which you need to take into consideration whenever you tune your workload, right? So as we will see. But nevertheless, so when I again execute the query, we can see from a query execution plan perspective that we have something here available, which is the output list, query store runtime stats in mem, so memory. And you can see I'm not able to move the mouse because otherwise the pop-up window disappears. But you can see the fifth line, actual number of rows is 8. That means this is these are the information which are currently kept in memory. They are not already flushed to disk because of the flush interval. You remember this kind of asynchronous write back. So we have currently 8 records which are kept in memory, and the other records, 90, as you can see, 90 runtime statistic records are already sent to the primary file group because of the asynchronous write back. So, and we will see later that this can lead to problems. Okay, so configuration. First of all, how to check whether when you have an instance with several databases, you do not want to use the GUI in order to figure out whether the query store is enabled or not. And again, query store itself has an overhead, as we will see. So therefore, it is always good to understand whether the query store is enabled and for which databases the query store is enabled, right? That is the DMV which you can use. It is sys databases. There's just another column, is query store on. Again, to enable the query store, with the default settings, you just have to alter database current set query store on. That's it. So we have several DMVs available, as already mentioned, just for the purpose for the sake of you're getting information about the current query store configuration. So there is one which is called this database query store options. And you can see there are a lot of columns available. And honestly, all the columns or all the information you can also see when you right-click the database, go to properties, go to query store, and you can see that the column names almost match the column names of the DMV. Yeah? There's slightly difference, but there are no additional columns available in the DMV. All of the information you can see here from that perspective as well. Personally, I'm not a very big fan about the GUI, but maybe you prefer to use this one. And for sure, you can change settings here of read-only, read-write. You can whatever you want to change. The other way around. Before changing something, it is good to know what you are changing, right? Because sometimes it is not getting better, right? So what is new in SQL Server 2019? So in 2019, we have 3 additional information, which is capture policy execution count, capture policy stale threshold in hours, capture policy total execution CPU time in milliseconds. That means you have more flexibility with regards to the queries where the runtime statistics and the plan information are collected. Maybe you do not want to collect every execution. So in SQL Server 2017, as we will see later on, there is a capture mode called auto. And I guess this was or is still the default. I don't know, but there is at least one, which is auto. Maybe I can open this again. Capture mode. Here. Currently it is set to all. We have auto, we have none, we have custom. So, and this is really, really important to understand. And I have an example later on, but I'm pretty sure I do not have enough time to go into this example. But I can already tell you what it means when you change the setting. So first of all means that you capture every query execution. So think about the implication. When you have when your database suffers from performance, and now you enable the query store, and now you collect runtime statistics and plan and the query execution plans for every query which is executed on the SQL Server, you can imagine this is not for free. It is not cheap, it is expensive. So therefore, there are other settings like auto. Auto in, I think in 2017, it was still, and honestly, the documentation from Microsoft is not very precise. I think Microsoft's official documentation will tell you when you select auto, the most expensive or the most relevant queries are captured. That means not all queries are captured, just the important one. But this is not true. The difference is it is not the most important. It depends on the number of executions. And in SQL Server 2016 and 17, you have to execute the same query at least 3 times until it is first collected. Yeah? Now it is 30. With SQL Server 2019, you have to execute the same query 30 times. That's not bad. But think about the following. Maybe you have a month-end query. Yeah? Maybe you're working in a finance company or whatever, and you have these kind of long-running queries in the end of the month. That means you execute the query once a month. When you set it to auto, this query is not even recognized. You do not get any information about the query. You cannot tune the query, but maybe this is exactly the query which you have to tune. You do not have any information available. It is definitely not even recorded. And again, there's another one which is none. Okay, I think I do not need to explain. Custom. And these are the new columns or the new settings which are available since 2019. You can define, and you can see the execution count. The default one is 30. This will prove what I already told. You can change the settings in a way that this reflects your workload and also the available resources, which is definitely a nice feature. But again, you have to know what you're doing. SQL Server have a lot of, or Query Store, this is also true for SQL Server, but Query Store have a lot of options. And the more options you have, the more important it is to understand what you are doing, right? Because it has a lot of consequences. So I will cancel this one just to know what you, and I will go further. Again, I will enable the query store, and please do not wonder. I just want to make sure that every, I call it chapter, can be executed independently from the former chapter. Therefore, sometimes you will see that I'm doing things twice. There is a DMV, which is database query store options. That is one which I already presented here. It's the same, just reduced to the 3 columns. We have an actual state, we have a desired state, and we have a read-only reason. So the problem is the following. Think about the following. You enable the query store, and the query store has a specific maximum size. Because again, all the information you need in order to tune and analyze and tune your workload, all the information will send to your primary file group. The primary file group, per definition, is limited, which is true for every file group. Yeah? And I guess you do not want to save a terabyte of query store data, just for analysis. It makes no sense. So therefore, it is always good to think about the maximum size of your query store. So therefore, we have 2 states. We have an actual state and the desired state. The desired state is the state you desire. That means normally you want to collect all the query information. That means query store should collect everything. The actual state can be different. So first of all, we will disable the query store. When I now execute the runtime statistics again, and I execute this query again, we can see the desired state is off, the actual state is off. That's not bad. Let's do the following. I set the query store, again to read only, and I ask the DMV about the desired state and the actual state. Both of them are read only. That is something you need to take into consideration, which is simple, but you need to know it. Now, let's go further. We enable the query store again. That means, the desired state is read-write, and the actual state is read-only. That is your problem already. That means you think the query store is functional and will collect all the data for you, but it doesn't, because of several reasons. So you can see, for example, read-only reason is one, which is databases in read-only mode, for example. There are several other things. I do not want to go through the examples, but imagine the following. I set my maximum, I can do it because this takes only a minute. Read, write. So I reset everything and I will run a query. I just create a table here, a very simple table, just a table with 10 records. I created a non-clustered index on top of it, just because I'm using the table over and over again for several examples, also to explain read lookup further later on. Okay, so I just reset everything and prepared one table with 10 records. So very, very easy example. What I'm now doing is the following. I concatenate a SQL statement. And because of the way I'm concatenating the statement, I produce a so-called ad hoc plan because it is an unsafe query. Because there are several ways to create an execution plan. It can be either a table scan or it can be a read lookup, dependent on the cardinality estimation. So therefore, this plan, which we are going to create here for the query, is unsaved. Therefore, we will end up with a so-called plan pollution. That means I will execute this query 500 times, as you can see in a loop here, 500 times. And I will do it in another window where I discard the result after execution, which is a setting, which means I do not want to see the result, but Instead, I only want to execute the query, which is a matter of a few milliseconds. What is going on here? Invalid column 2. I don't know. Column 2 should be there. That's interesting. It is already. Oh, 1 second. I just need to check what is going on. Let me see. There is a column with a column 2. Okay, interesting. Column 1, column 2. Maybe I forgot to execute. No. Clear. If it is not working, I will skip this one. Select test from where column is equal to whatever. Just give it another try. Okay, in the wrong database. Sorry. I need to use AdventureWorks. Perfect. So this time it runs just for 1 second. If I do the same exercise with not enabling discard result after execution, it will take roughly a minute. I do not want to wait a minute, and I guess you do not want to wait a minute just for seeing that the query is executing. Okay, so what you can see now is the following. I have a plan pollution, 500 rows. Because of the plan pollution, the query store, which currently captures all the queries, 500 queries, collects the runtime statistics for every individual query execution, even if it is the same query which we will repeat over and over again, just with another parameter value. This is so-called plan pollution. This is something you normally want to avoid. There's several techniques to avoid this, but this is out of scope here. So you can see that the current storage size, sometimes is 0, this is 1, perfect. So the current size is 1 megabyte. So you can see when I execute this query again, so the query store runtime statistics, most of the information are kept in memory. You can see the number of rows is 506. That means currently the size of the query store is just 1 megabyte because the information, the runtime statistics, are not sent to the primary file group. So we can force this. We do not have to wait 15 minutes, which is the default. We can flush the in-memory query store information to disk by execute this sp query store flush db. And now all the information are sent to the query store. That is why my query store is 2 megabyte big this time instead of 1 megabyte. So, and for sure, when I run this query again, this query store runtime statistics, I can see that this the concatenation with the in-memory query store information, you can see that the actual number of rows is just 3. All the other information are sent to the primary file group. So what happens now if I resize the query store? I didn't remember the actual size, honestly. This is 2. Okay, sometimes it is 3, sometimes it is 2. I will resize the query store to 1 megabyte. And believe me, I'm just doing the example to avoid that I need to run 1 million queries so that the query store will increase to, I don't know, 1 gigabyte or whatever. I do not want to ask you to stay with me in a session just to produce a workload, which takes 15 minutes or whatever, just to see a size of 1 gigabyte. But you can imagine the problem is still the same, even if it is 1 megabyte. So I now try to resize the query store to a maximum which is less than the current. So normally you should expect this will give you an error, which is not the case. So the query store accepts the new maximum size, which is less than the current size. You can see it. It's a little bit odd. But what happens now is when I execute another query, just one query, one additional query, and I will flush the memory portion of the query store to the file group. And again, I ask the query store about the current size, so it's 1 megabyte. The maximum size is 1 megabyte. I have a read-only reason, which is 65536. And you can see that the desired state is read-write. The actual state is read-only. you do not get any information somewhere that your query store is not functional anymore because the maximum size is reached. I guess this is some, how can I put it? For sure, you can track everything with extended events, but I don't know. I personally, I do not like it. So normally I should see a message, which tells me, okay, query store, the desired state is a read-write, but the actual state is read-only because the size is reached. Okay. This is something we need to worry about. This is something you need to monitor to make sure that you're not losing information because, for example, the maximum size of the query store is reached. You can always extend the current size of it. But again, every disk, even Azure, or the other way around, every disk is limited. And even if the disk is not limited anymore, you have to ensure that you extend the size of the primary file group, because normally I do not recommend to leave the size unlimited, right? Okay, so that is maybe a pitfall. The flush interval in seconds, that is also something you need to understand. I will just go through the code. I do not want to execute the code, but I guess you will get it. So the default is 900 seconds, which is 15 minutes. That means every 15 minutes at maximum, there is an internal smart algorithm which makes sure that the in-memory information which I have is not that big that it takes ages to send this information to the primary file group. So that means it is a maximum of 15 minutes. So why 15 minutes? Why not a minute? Why not a millisecond? Because think about the impact. Whenever you execute a query, normally you have already a plan in cache, which is a synchronous write-back. But for the runtime statistics, you might use the same query over and over again, maybe with different parameters. Therefore, you will have different runtime statistics. These kind of runtime statistics is in one-to-n relationship to one query. So you have one query with n runtime statistics, but you only have one query with one plan. For sure, we can talk about ANSI settings and you have more than one plan, but this is not the case. You already understand that the workload or the information I need, a SQL Server needs to collect, this is not the plan. These are the runtime statistics. And that is the reason why SQL Server implemented a flush interval in seconds, 15 minutes, to make sure that you have something like a trade-off between, or a balanced trade-off between the physical I/O you generate by writing the information to the primary file group, so physical write I/O, and the information you have in memory. And now you need to consider the following. When SQL Server crashes, then the information, the maximum runtime statistics you can lose is roughly 15 minutes. Okay, that is not bad. That is much better than the traditional DMVs, because again, the traditional DMVs are completely flushed. There's nothing which is kept, nothing which is persisted. The problem is the following. There are two trace flags. As we will see here, yes, there are two trace flags. There's a trace flag 7745 and another one 7752. 7752 is already implemented in SQL Server 2019 because of several reasons, because of performance reasons, as we will see. But let's talk about 7745. The problem is that you can see the trace flag 7745 prevents the default behavior where query store write data to disk before SQL Server can be shut down. That means that the query store data that has been collected, so the in-memory portion, a maximum of 15 minutes per default, has been collected but not yet persisted to disk, will be lost up to the time window defined by data flush interval in seconds. So that means when you enable this trace flag, it prevents the default behavior. That means whenever you shut down your SQL Server in a controlled way, or maybe think about an always-on availability group, a cluster or whatever, you want to fail over to another cluster, to another node, to whatever, the information which I have currently in memory, which is maybe 15 minutes of runtime statistics, all the information have to send to the primary file group before you can shut down SQL Server or maybe fail over to another node, which can take time. We are not talking about milliseconds. We are not talking about seconds. For sure, 60 seconds is a minute, but you know what I mean? I would say 15 minutes in a busy system, I would say in-memory query store information will take a few minutes to write to your primary file group. And for some scenarios, for some high availability, I would say applications, this is a showstopper. It cannot work. So therefore, when you enable the trace flag in your startup parameters, for example, 7745, it means you are willing to that you lose data whenever this happens because you do not want to wait. There's another trace flag I already mentioned with the 7752. That means enable asynchronous load to query store. The problem is the following. When SQL Server now starts, all the query information you have in your primary file group are sent back to the in-memory part of SQL Server in order to give the user a much better user experience when the user uses the query store reports. But this takes time. And this will block, because when the query store is enabled and you have decided to capture all your queries, SQL Server cannot execute a query until all the information are read from the primary file group and sent to memory, which can also take a few minutes. That means your recovery time of your SQL Server is, how can I put it? It takes longer. It takes longer than you expect. And this is another concern, maybe another business concern, because normally the business wants to have the SQL Server back as fast as possible. And I guess they are not willing to wait a few minutes until the performance tuning one-time statistics data are sent to SQL Server. So this should not be your priority in most of the cases. And you can see this trace flag is now part of SQL Server 2019, as you can see here. Okay. So in order to see whether you suffer or if it is worth to enable the trace flag 77452, there's one wait stat. You can see this DMO is a wait stat named QDS, Query Data Store, Load DB. That is exactly the time it takes when SQL Server restarts and has to send all the information from the primary file group for the query store to SQL Server. So when you can see a high wait time, it is very likely that when it is a business critical application, it is very likely that you will definitely benefit from enabling this trace flag. And again, Microsoft decided to implement this by default in SQL Server 2019. That's the reason. Memory clerk. Before we are going to the report to show what I can do with query store, so we covered the configuration. We covered some pitfalls already, and this is another big pitfall. Honestly, this is something I have seen by at least 2 customers already. We enabled the query store on a large SQL Server environment. And after a while, the customer gave me a call and told me my SQL Server, the database, does not respond anymore. Okay, so we figured out that the memory consumption, which we can see in memory clerks, this is something I want to present or demonstrate in a minute, was extremely high. That means you run or SQL Server run in a memory contention, which makes the SQL Server database almost non-operational. So the user really have to wait for the query store. So we disabled the query store and everything was working as before. So again, nothing is for free. So let's do the following. I will enable the query store here. Create a table called test. It's the same table over and over again. 10 records. Create a non-clustered index on top of it. I will clear the plan cache just to make sure that I have an empty plan cache. I will also clear the information from the query store just to reset everything, nothing else, just to reset everything to make sure that the exercise or the demonstration always works. We can see the state is read-write, the desired state is read-write, which is perfectly fine. And when I now execute this query, so this is DMOS memory clerks, which gives you information about, so by the way, there's so much more. So we have not working. This DMOS is invalid in this select, because I have a sum on top of it. Let's do it like this. So we have 390 different memory consumers, as you can see. But you have to be very precise. This is true because I have only one NUMA node, because you have memory clerks per NUMA node. This is my personal laptop. I have only one physical core and one logical NUMA node with 8 cores. That means currently in SQL Server 2019, we have 390 different memory consumers, I would say. And there are at least three memory consumers, memory clerks for the query store. So we can see that we have, let's go up, the query disk store stats, the query store hash map, and the query disk store. So the store hash map is the hash table of the query and plan for the instance. This is the largest memory consumer, as we will see, and this can be your bottleneck, right? And this will be repopulated from disk at startup. You remember the 2 trace flags, 7752? This is exactly to prevent that repopulation happens synchronously, okay? There's another memory clerk, query store disk store. So these are the general clerk for overall query store, in most of the cases really small. And then we have the disk store stats. These are the table. This is a table, or it is not a table, but okay, in the end it is a table, but for sure it is the memory part, the memory clerk for the runtime statistics. So let us do the following. So let me copy this because I cannot predict the value here, but it's almost always some kind of the same. Just to compare it, I need it only once. So this is the current memory allocation. And when I now run the unsafe query, this time I run it 5,000 times to produce some workload and also to produce runtime statistics for the query store. It takes roughly half a minute, I would say, dependent on my laptop. It's very late already here, so therefore maybe it takes even a little longer. Oh, okay, 9 seconds, that's not bad. Okay, when I now execute the same query again, we can see what happens. Just for 5,000 query executions, I have 7 megabytes memory allocated for the query store. And this increases over time. That means, again, there are situations where your current workload competes with the memory, because the query store already allocate memory. You can see this is the current memory allocation for roughly 5,000 runtime statistics. Okay. You can see that all, and this is definitely the plan pollution, as we can see here. Every query, this is a plan cache, cache plans. Every query, which is almost always the same, just the parameter change, but it is still an unsafe and therefore ad hoc plan. So you can see here ad hoc. So we created 5,000 ad hoc plans. This is definitely something you want to avoid. And again, there are definitely techniques to avoid this, force parameterization and do it the right way. And I do not want to talk about this, but I just want to make you aware about the memory consumption. It is not for free, which definitely sometimes can really cause really big, serious performance problems, right? So now I disable the query store, and you can see what happens by just altering the database. I already mentioned either enabling or disabling. It doesn't really matters because I alter the state of the database. Therefore, all the plans which I had in cache are gone. They're gone. They're not there anymore. Let's do some housekeeping. So I will skip this one and go to another section. Weight statistics. So think about the following. You think your SQL Server is slow, and maybe you are already in Azure, or you want to migrate your on-premise instance to an Azure instance, which is either VM, SQL Database, or managed instance. By the way, managed instance is a really amazing feature, amazing product. So it's definitely great. So, but the problem is not the problem. It is also a benefit, because what happens? You have your on-premise machine. You spend already a lot of money for CPU, for memory, for your disk. And in the end, I would say performance tuning is, you will only do performance tuning when someone complains. It means the business complains about slow or long running queries. Okay, then you start, this is, I would say, the exceptions, but then you start with query tuning. And maybe in the end, you find an appropriate index, everything runs fast, everyone is happy. So from that perspective, I would say you already spent money for your hardware. In the end, it really doesn't matter how fast your SQL Server is when it is not a business critical instance. In Azure, this is completely different. For disk, for CPU, for memory, for your resources, you are paying money. That means when I have a managed instance, which maybe costs you 20,000 euros per month, when I now have a system which is tuned, where the workload really scales, where you have the right indexes in place, right? That means you can reduce your resource consumption because you do not need that much memory, that many cores. And yeah, disk is not a problem, but you know what I mean? I can reduce my resource consumption. Because of that, I can immediately downscale my managed instance, for example. And therefore, and this is true for VM, this is true for SQL Database as well, and therefore I can save money. That means in Azure, performance matters even more from a cost perspective than on your on-premise machine. Because again, you already paid for your hardware. Who cares? But in Azure, I can immediately downscale, and for sure I can also upscale. But normally I want to downscale in order to save money on a monthly, daily, I don't know, base. That is your goal. That means performance tuning becomes is more important than before. And therefore the query store, as you already understand, will support you on analyzing your query workload and finding the right strategy to reduce the resource consumption and to reduce costs. Okay, so there's definitely one pitfall. So when you think about what is query, or the other way around, the business normally complains about bad performance when queries are running slow. They do not care about memory consumption, CPU consumption, or whatever. They do not care. They do not even see the memory or CPU consumption. What they see and what they recognize is that they have to wait, I don't know, 10 minutes for a query, which is definitely too long. And in most of the cases, they're even right. You can do it much better. The problem is that the elapsed time, the query execution time, is nothing else than the elapsed time. And the elapsed time is the sum of your CPU time plus wait time. The problem now is, without having the query store, it is not impossible, but for historical workload, I would say this is impossible for historical workload, because normally what happens, the business calls you and tells you, oh, yesterday the query was slow. That's great. That is really the moment where you think, okay, that's good to know. Now I will create my extended events, hopefully not using the profile anymore. Maybe I will, whatever I will, in order to capture and hope that the same query is executed from the business again, and hopefully it is the same execution time as before. And the problem here is when we have the query store enabled, we can see that we have run long-running queries, and we can also see that the root cause of the long execution time is not because the query itself is slow, but maybe it is because it has to wait on a specific resource, maybe for a log, which is not compatible with a log the query is currently trying to, what is the right word? Yeah, trying to get. Yeah, I will give you an example. So I have an explicit transaction here, begin transaction, update the table test, which I created. It's always the same table with tablog even. And I do not commit or do not roll back the transaction. So the transaction is still open. So you know that SQL Server per default runs in read committed. That is the default transaction isolation level. That means reading data needs a shared log. Writing data needs an exclusive log, yeah? To make it very simple. And in your pessimistic concurrency, which is read committed, the entire asset rule works because of blocks. That is a mechanism in order to avoid inconsistency. And therefore, when we now try to read the table in another session, let's do it. This session for sure is blocked. It's not blocked. Why is it not blocked? 1 second. So it's here, run another session. Okay, let's give it another try. Roll back everything. Test in AdventureWorks. Okay, I know what happens. There was an open transaction somewhere. I did the same. I prepared for the session, and I'm pretty sure that there was an open transaction somewhere. So that means everything what I have presented so far was running in the transaction. So therefore, I just need to make sure that I repopulate and recreate the table. Let's do it. Okay, go back. Oh no, that's too much. Here we go, right? Reset. Yes. Okay, let's give it another try. It's a little bit strange now. I do not have an open transaction anymore. Okay, give it another try. At least the transaction is rolled back. So use AdventureWorks drop table. It is not there, but I will drop it. Create table. Yeah, create table. Insert 10 records. Create a unique index on top of it. Okay, let's go back. Try it another time. Nope, wait statistics. Okay. Reset the query store. All the data is not allowed within a multi-statement transaction, but I cannot see that I have an open transaction, honestly. I have one. Maybe here. That is maybe the problem. Okay, I will close this one. Sorry for this, but sometimes you cannot foresee it, what happens. And this is usually not what I expected. Okay, roll back, select log, add run count, 0. Okay, another time. It's a little bit strange. Use AdventureWorks, create a table, insert a few records. We see there's no explicit transaction here. Let me do the following. Create, perfect. Yeah, but okay, that's good. Okay, sorry for this, but I do not see the problem here. Maybe you see it already. Okay, again, okay, that works, perfect. And now I will begin. Yeah, I will begin the transaction update test. Set column 1 is equal to -1, where column 1 is equal to 1. Okay, nice. Perfect. Okay. Don't ask me. Sorry for this, but yeah, don't know. Great. So the problem is the following. I have an open transaction with an exclusive lock. So, and I can identify the locks. So I have my own DMV. It's not my own DMV. It's just another way to reveal the locks. And we can see that in session 62, we have a lock, which is an intended shared lock. That is the session which tries to read the table test. And the other session currently holds the X-lock. You can see the X-lock is granted. X-lock is not compatible with an intent shared lock. Therefore, the session is blocked. Okay. The problem is the following. When we now use the query store and just judge the query performance by your elapsed time, this query will be maybe your most prominent query because it takes ages. The problem here is that without having the query store in place, it is almost impossible to understand that the root cause of the long-running query is not the query itself, but it is another query. Because this query is the fastest query ever when it is not blocked. Means when I now roll back the transaction, and this time, just to make sure, perfect. I do not have an open transaction anymore. It's great. So the other query immediately is executed, but it took almost 2 minutes. So that is exactly the situation where the business will give you a call and tell you, oh, my query is running horrible slow today, please investigate. Okay, how can I do it? No way. For sure, I can go to DMO with wait stats, but this is just an aggregated view on your wait stats. I cannot see that this specific query suffers from a log. This is something which you cannot do. You cannot see a log from a query which is executed. Okay? With query store, you can do it. So first of all, you can do the same, by the way, for all. Come on. Okay, now I have another query hash. It's a little bit strange. I did the same exercise directly before the presentation here. I know what happens. The query store was not on. 1 second. I just need to check whether the query store is on. I guess, no, it isn't, because the problem is that this was part of my user transaction. Query store capture mode all. Okay. Sorry for this. I need to do the exercise again, but this time it is really easy. I just need to execute this session here. Sorry, I'm a little bit confused now. Wait. Yeah, wait statistics. Okay. Okay, I do not have an open transaction, hopefully. Nope. Reset everything. Begin. Perfect. Go to the other session. Wait for a moment. Perfect. That should be sufficient. We know already that the query is blocked by the other query. Oh, come on. So again, we can now use the query store in order to go back to the historical execution. Because again, this DMO's wait stat is aggregated. This DM exec session wait stat is something which only works on a session level, but also aggregated. This DMO's waiting task is only working when the query is currently executing, which is not the case anymore because the query is finally executed. So when I go back, and hopefully the query hash this time works. Yeah, this time it works. Perfect. So this is what we can get from the query store. You can see all the information I get from the query store, and I can also open the report. Let's go to the top resource consuming queries. Because I resetted the entire query store, I only can see one query here. So this is the total execution time. And maybe you think, oh, this is definitely worth to tune. Right. But it is wrong. We have to go to wait time, and we can see that this query here suffers from wait time. Almost all the time of the elapsed time, the query was waiting for a resource, which is in our case, the shared log, which is not compatible with the exclusive log. So this is definitely a big benefit of the integration of the query store. We can even go back to the history in order to see what is the root cause of your query, of your long-running query. Yeah, that is definitely something which is perfectly fine. When there are a few other things you need to consider. When I go back to the total execution, total consumption time. Let's go to another report. Resource consuming. Yes, duration. So when I execute the query the second time, let's do it. The one with the select. It's still open here. Yes. Only, not even a minute, not even a second. When I go back to the report now and refresh, we can see that there is something available like the standard deviation. And this tells you that the higher the deviation is, the more volatile the execution time is. And again, you have to worry about CPU time, and all the informations are here. So you can see the CPU time when you change the configuration and go to CPU time, something which I do not want to do, because this is something which you can do with T-SQL much better than you can do it with a report. But again, concentrate on the CPU time and try to figure out why the query is running that long. Even the CPU time is, I would say, neglectable. That is why query store, again, that is why query store is that handy. That is something which is so hard to do with a traditional approach. And this is not a root cause, as the root cause is a blocking locking situation. You do not have to spend more money for better hardware. You will never ever get a better performance because a lock is there. A lock is there until you release a lock, until you commit or roll back the transaction. Do not spend money for something like this. Okay, I just want to make sure that I do not have an open transaction here. I'm really a little bit confused. Okay, perfect. This is what I expect to see, but I did the exercise even 3 times, and I expected to see no open transaction. Okay, wonderful. So the next thing I would like to present is, I just want to go down. Down. What do we have here? Capture mode, I already told you 30 times, 3 times. Regression. So we have two things I want to capture. First of all, what is a query regression? So a plan regression, to be precise. It is not a query, it is a plan regression, because the query is executed with a new plan, which can be either better or worse than before, depending on the selectivity of your parameter set. And there's another thing I want to cover, and this is a very common problem. And this is definitely something you have to do on a regular basis, or even when you decide to migrate from your on-premise machine 2017 or whatever, to an Azure managed instance, which is almost running in the latest version of SQL Server, which is 2019. This is about the Cardinality Estimator. So 2 things I want to cover with regards to the query store, because I guess it is definitely worth to know about the problems here. First of all, I will create the same table again, just to make sure that everything is working. Create a non-clustered index on top of column 2. Very easy. So you can see this is a table here. We have a lot of records here. So we inserted 100,000 records, but I inserted the records with an uneven distribution, and you can see it here. We have 100,000 records, and we only have 2 distinct values in column 1. That means it is very selective, and we have a non-selective column 2. So this is as usual, well, not column 2, sorry, I mixed it up. There are 2 values in the same column where I have non-clustered index on top of it, which is column 2. You can see there's only column 2, but I have an uneven distribution. That means one value is very selective and another value is very unselective. So this is a very typical problem. So I will reset my plan cache, reset my query store, and ensure that the query store captures all queries. So just to reset everything to make sure that the example works. I create a start procedure, which is really easy and very common. Select all from DBO test, where column 2, this is a column where we have the non-clustered index on top of it, is equal to the parameter column 2. Perfect. I enable statistics IO on just to see the number of logical IOs. And I execute the query the first time. That means the query execution, or the query engine, now compiles a plan based on the parameter. you can see the parameter currently is 0. And let's enable the execution plan. And we can see, because 0 is a non-selective parameter, SQL Server tend to use the table scan, okay? Because the cardinality estimation will tell SQL Server it is very likely that you will get a lot of rows back. So therefore, do not use the non-clustered index, which is there on column 2. Instead, use a table scan. That is, by the way, called tipping point. So whenever SQL Server calculates that it has to read more than 1/3 or something between 1/3 and 1/4 of the entire pages of the table, when it is more than that, SQL Server prefers to use a table scan instead of a so-called bookmark lookup, which we will see in a minute. So I will open the statistics, and for sure the statistic name is the same name as the index, because every index has to have in statistics. And we can see that this is the statistics header, this is the density, this is the histogram, but the most important one is, first of all, two important things here. First of all, we can see that the equality rows is almost every row when we pass the parameter 0. That is why SQL Server decided to use a table scan, which is much more efficient than the bookmark lookup, as we will see in a minute. For the other value in column 2, which is 1, SQL Server estimates that we will only get back 10 rows, which is a very selective value. Okay. The statistic was created at 12 a.m. 26, and when we now insert more records into the table, there's a threshold, which is, I do not want to make it more complicated because there's a DBCC trace flag for SAP integrated, and this is by default now integrated since, I don't know, 2017. Make it easy for the moment. When you insert more than 500 plus 20%, or not insert, when you change the existing records in a table, more than 500 plus 20% by either changing or inserting, the statistics become stale, and per default, auto statistics on, SQL Server will recompile the statistics and will create a new execution plan for you. This is a recompilation caused by a stale and then renewed statistic. So that means I need to insert 20,501 row. Just to make sure that everything is working, I insert 3 records more. So that means or by makes no sense, but okay. I'm inserting additionally 20,504 records to outdate the statistics. When I now execute the same sort procedure with the selective value, you can see what happens. The plan we had before with a table scan is replaced by a so-called bookmark lookup. And to be very precise, we have 2 bookmark lookup, which is a read lookup or a key lookup. In this case, it is a read lookup because we have a non-clustered index on top of a heap. Okay, that means when we now, hopefully, when we now get the I/O statistics, SQL Server only uses 17 logical reads. Sometimes it is 18, and it's not very predictable. And going back, and this is something I forgot to show you, but you can see that before, because the table scan has to scan the entire table, that means all the pages which belongs to the so-called index allocation map page, which identifies all the pages which belongs to this table. Yeah? So we have 211 logical reads. So remember, one page is 8 kilobytes, by the way. So this is by, it looks like that this plan is much better. So you can see the root cause of the problem, it is really a problem, is that the statistics are recreated. Therefore, we get a new plan because of the recompilation, because of the stale statistics. And again, this time we have a very selective parameter value, which is 1 instead of 0. And therefore, SQL Server estimated, you can see the estimated number of rows is 13. And by the way, we can see this here. So I cannot move, but the mouse pointer is almost there. Estimated number of rows to be read 13. This is SQL Server, just use the available histogram. Okay, cool. So now I will flush the information to the primary file group for the query store. That's perfectly fine. When I now go to my, top resource consuming queries, I should see this query, but I can see I have 2 plans. That is the first plan for the same query. That was the first one with the non-selected parameter, the table scan with 211 page reads. And the other one, that one, is a grid lookup, the bookmark lookup. So what people now can do, and personally, how can I say it? I do not like the integration here because it is so easy to say, force this plan. And I have seen a lot of people forcing plans because from a reporting perspective, I personally and also fully agree that this plan looks much better because what we are doing is so the current configuration is duration, again, elapsed time. The elapsed time of this plan is much better than this plan, but this is exactly the same query. Okay, why not forcing this plan? Why should I spend more time when I can have another execution plan which does a much better job? Cool, let's do it. And this is, by the way, almost the same like automatic plan correction works. Automatic plan corrections is a little bit smarter. Yeah, I do not want to blame the feature. I like it. Yeah? But I do not want to go into this discussion now. Let's do the following and force the query, this query plan, force the query to use the better query plan. You can see there's a hook in the middle. It's hard to see, but believe me, there's a hook in the middle. That means this plan is forced. Perfect. I did a great job because what happens now is the following. Let me close this session. And honestly, I will close a few windows here because otherwise I'm completely lost. The more windows I have open. By the way, there we can do the same here with SP query store force plan, and then we have to give the query ID and the plan ID. So this is what we have done here manually. Yeah? So perfect. When I now execute the same query as before, I just want to show you the same query. So this is exactly the same query with the same parameter. It's perfectly fine. I have a grid lookup. I did a great job. But honestly, I didn't change anything because the parameter value is the same. Now, I run the same query with the non-selective parameter. And now the problem starts. When we go to the logical IOs, we can see that we have something about 120,000 logical reads instead of 211. So what the heck is going on here? The problem is the following. You can see this plan. Be hard to find the mark. Zoom to fit. So you remember that we asked SQL Server to force the bookmark lookup, the read lookup for this query. It means SQL Server does not even consider recompiling the plan, as we will see. It will always, and even if you restart SQL Server, it will always reuse this plan because this plan is persisted because it is part of the query store. That means it will also be available when you restart your SQL Server. The problem is the following. We will use an index seek on non-clustered on the non-clustered index for column 2. And you can see the problem here. The estimated number of rows to be read is estimated as 13 because this one, the estimated number of rows, this is the estimation for the selective parameter. That means this is coming from the plan cache. The actual number of rows, as you can see in the first third of the pop-up window, think about 120,491. That means for every match in the index seek, SQL Server has to read the additional information because column 1 is missing. We only have a non-clustered index on column 2, but we are asking for all columns of the table test. And the index does not include column 1. So therefore, the missing information needs to be SQL Server needs to get the information from the heap. It means we have an outer and an inner query, and we have an iteration. A nested loop will not scale. That is a problem. A nested loop is something which definitely works for a small workload. That's perfect. That is a very nice algorithm, but it will not scale, and it will not work with 120,491 records. The problem is now when I go back to my query store report and I refresh, what happens now? This plan was a plan. This was the first plan. This was the second plan, and I just want to make it because I guess I executed this twice. No, it's the same. Okay, no worries. So this was the first execution, the table scan. You can see it. Now then we executed the query again after recompilation, and this is a read lookup with 18 lookups, lookups or logical reads. It's almost the same here. And now, because this plan is forced, it will use over and over again, completely independent whether the statistics become stale, whether you restart your SQL Server, or even, and this is really hard, implement the right index. Even if you implement a covering index, like create non-clustered index on column 2, include column 1, maybe create a clustered index, maybe create a non-clustered index with column 2 and column 1 in your navigation structure. Not an include one, but instead is the index keys. The same plan is still used. And this is something I do not like. That means everything you are doing in order to tune this query now is completely meaningless until you unforce the query plan. This is so dangerous. Do not do this, please. Please do not do this. So that is about, and okay, we can do it. Create a covering index on column 2, including column 1. It's a perfect index for this query. Run again the query. Even with recompile, even with a new index which is fully covering, we can see that the index is not even considered. It is still the plan we forced. Recompile, creating the right index, it is completely ignored. Really, 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 really dangerous. So what I will do instead is, or what I have to do is, I will unforce the plan, because it is not forcing the plan or unforcing the plan. It is about thinking about what is the root cause that the variation, the standard deviation of the elapsed time is that high, because sometimes it is fast, sometimes it is slow, dependent on the first compilation and dependent on the parameter of the first compilation. The root cause is that we do not have a covering index. So we created the covering index already. When I now execute the same query, either with a non-selective parameter, we get the index seek with 330 page reads, which is a little bit more because of the balance tree architecture. When I now execute the same query with the I think this is a selective parameter, right? Yeah, this is a selective parameter. I get an index seek, which is perfect, which only 3 logical reads. That is the way to fix it. Please do not fix queries by forcing a plan. That is not the right way to do it. Query store at least will give you good insights. But again, this is something normally I do not like it, that it is so easy to do it. Okay, I know that I have 15 minutes left, perfectly fine for the last example, and then we are done. I need to go down, down, down. I need to go down. I think here we go. Nope. I think there's so much to cover, but cost threshold for parallelism. One second. Cardinality estimator. Cardinality estimator. Yes, here I guess we go with the cardinality estimator. That is my. Nope, I'm not here. Yeah, here. That is my favorite. And that is Microsoft recommends to use a query store whenever you do an in-place, not even an in-place migration. When you migrate from a former SQL Server version to a newer SQL Server version. Currently, I have a few customers. All of them complain about the situation that the majority of the queries will run much faster within the SQL Server 2019 or 2017, but a few queries are definitely so much slower, really so much slower. So it is really, 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 really slower. Yeah. So, and people are wondering what is the problem here. So SQL Server 2019, so performance really matters. And, Microsoft is really pushing SQL Server 2019 and they're doing amazing improvements here, really. But why the hell do I have queries which are running slower than before in the newest SQL Server version? Okay, that is where the query store is very handy. And again, Microsoft even recommends to do it like this. So I will show you with the example and then I will tell you how you migrate. Not just press a button and migrate and think everything is fine. This is an easy upgrade, but it will not work. So let's do the following. There's a formula for conjunction and for a disconjunction. A conjunction is an and. Yeah, I have a predicate with 2 columns, which are combined with an and. It means column 1 is equal to something and column 2 is equal to something. The disconjunction is I have a predicate which is column 1 is equal to something or column 2 is equal to something. A conjunction and a disconjunction. So there is a formula. When I execute this, we can see that we have, and this is the estimated number of rows. This is, as we will see, for the moment, just remember the values, nothing more for the moment. I will tell you what it is, but first of all, we can see that there is a different estimated number of rows for the legacy cardinality estimator for conjunction, so for an and, is, 500,000. For the new one, it is 707,000 rows. This is the estimation for a conjunction. For a disconjunction, you can see that there's also a difference. This is 1.5 million compared to roughly 1.3 millions. So you can see that depending on the version, because with almost every version, at least for the latest version since 2014 or 12, I guess, we will have a new cardinality estimator and this is the cardinality estimator. This is a formula SQL Server will use internally to estimate the rows the query very likely will return. Okay, good. Okay, and what I will do is I will execute this in another window that we can always go back, because otherwise I have to execute the query over and over again. So just because I'm already tired, yeah, I cannot even remember it anymore. But we create a table test now. And what we will do is we will populate the table with 2 million records, exactly like we have in our formula. And we also have equality rows 1 million, and that means we have 2 unique values for the first column, 2 unique values for the second column, which is exactly the values we already used in the cardinality estimator algorithm. Okay, let's create the table. But let's insert the data. Take roughly 30 seconds. Should not take that long. So and after, oh, okay. It's much faster than I expected. Okay, now I will create the statistics just to make sure that I have a statistics with full scan. You know that with increasing number of records, SQL Server tend to decrease the number, the so-called sample, which is a complete different story. Yeah? Full scan means it will entirely scan the table in order to get a precise statistics for column 2 and for column 1. Okay, so now I need to sheet because this is something I cannot predict. Let me do the following first of all, because sometimes it is 16, sometimes it is 19, this time it is, that is nice. This time it is 15, okay, fine, good. Okay, so what I will do is I will change the cost threshold for parallelism to 15, okay? Sometimes it is 16, sometimes it is 19, it's really hard to predict. It also depends a little bit on my CPU and a lot of other things, okay. Nevertheless, cost threshold for parallelism is set to 15. And again, this is just one example, which I can repeat, and therefore I decided to use this example. Maybe in your environment, your cost threshold for parallelism is not 15, maybe it is 50. But nevertheless, the behavior and the consequences are definitely the same. It is just a matter of setting your cost threshold for parallelism. By default, it is 5, but you have to set it. Okay, so you have a value here. I decided for 15. I will enable the statistics time on, flush the procedure cache, and set the database to Cardinality Estimator 70, 110. I guess this is 12, SQL Server 2012. I guess it is 2012. I cannot remember this anymore because I do not understand why it has to be 110 when it is 12, why it cannot be 120. Then it is much easier to understand which version we are using. But okay, that's a different story. So I guess this is SQL Server 2012. And SQL Server 2012 use a cardinality estimator 70, which is exactly the legacy cardinality estimator. Yeah? This is the cardinality estimator which is used in this algorithm, which estimates this number of rows. Okay. So, by the way, I will close this one. When I now execute this query, I force a serial plan with the old cardinality estimator, a serial plan, and okay, this time is 16. Sorry, I need to go back because otherwise the example is not working. It was really hard to figure out how it works. Therefore, I really have to ensure that I need to adjust this because otherwise the example is not working. 16, perfect. So when I run this query single-threaded maxdb1, the cost of the query is estimated at 16.8965. again, this is the estimated subtree cost. Estimated is not your actual cost. This is based on estimations. So it is never, ever precise. So I will restore my query store. Just ensure that the query capture mode is set to all, because otherwise, you remember, I need to execute the query several times that I can see the information in the query store. So when I now execute the query still with the old legacy Cardinality Estimator 70 in SQL Server version 2012, which is compatibility level 110, I hope that's right. At least it is not 19 and it is not 17. We can see what happens. Perfect, it works. We have, because this time I do not limit the query to run single-threaded, as we limit to run the query single-threaded. Instead, because the cost threshold for parallelism was 16.8, which is higher than the current threshold for parallelism, which is set to 16, SQL Server considers to run the query in parallel. That means it will compare the actual the estimated cost of the single-threaded plan with the parallel plan, and decided it's much better to run the query in parallel. That means it uses more CPU in order to hopefully, in my case, 8 CPUs, as you can see here, in order to reduce the overall elapsed time. So what happens here is the following. So the CPU time, it's almost, no, it's not comparable. So let me copy this, because this is also something I cannot predict, but the number of logical reads is the same. Yes, it's the same. Okay, so we spent 1.3 seconds on the CPU, and the overall elapsed time is 236 milliseconds, because again, this query runs on 8 CPUs, so therefore the CPU time is higher than the elapsed time. Okay, but in the end, this is what the user will see. This is what your SQL Server will see. So this is the hardware consumption. Now I set the compatibility level to the new Cardinality Estimator, here in this case SQL Server 2017, which mimics the migration from an old version to a new version. That means you migrate to a new version, SQL Server 2017 or 2019. Okay, just replace the existing version with a new version. There are several ways to do it, but this is what you get. And this is what most people do. They do not worry about query store or something like this, just migrate. The problem happens with this query. Now I execute the same query, and you can see this is still a conjunction with the new Cardinality Estimator. I guess this is Cardinality Estimator 120. I don't know. Let's figure it out. This is a new plan. It's completely different than the other one. The other one was a parallel plan with a sort, with a hash, and I didn't even remember anymore. So let's compare the CPU and elapsed time. So, and this is not the truth. Once CPU time. I just need to copy this from this query here, so that we can see now and before. Cool. You can see what happens. The elapsed time of this query with the new Cardinality Estimator, because the plan is completely different, is 2.5, 3 times higher than the plan before. So the user experience is not as good as before after you upgrade. Okay, what is the problem? The problem is the following. The estimated number of rows in this scenario is, because of the new Cardinality Estimator, it's somewhere in the middle. You can see it 1.3 million. And before, I do not want to execute the query before, but you can believe me, before it was 1.5 million. This is exactly what we already estimated for our disconjunction, right? We have an OR. So that means whenever I have an OR, and this is really, really, really hard to tune, as we will see, a disconjunction is really bad to tune. A conjunction is not a problem. We can easily create either a composite statistics, or we can create a composite index, which covers both columns. That is not a problem. Then we get a precise statistic, and we also get a wonderful index which fully supports the conjunction. A disconjunction will not work with an index because a disconjunction is either or, so we cannot use an index, right? So this is the reason why I decided to use a disconjunction here. So again, the actual number of rows is 2 million. The estimated number of rows for the new cardinality estimator is 1.3 million. The estimated number of rows for the legacy cardinality estimator is 1.5 million. Which plan is better? Think about it. The plan, the costs, and the overall query execution plan, the selection of the operators, or you can call them iterator, it depends on the blog article you read, is only dependent on the estimated number of rows. The cardinality estimator, and for sure memory, CPU, but this is nothing which I changed. So memory and also cost ratio for person, I didn't change anything. That means the cardinality estimator will determine the structure of your query execution plan. The old legacy cardinality estimator estimates 1.5 million rows, which is much closer to 2 million rows, because in the end I get back 2 million rows. I get back 2 million rows actual reads, because I need to aggregate the rows. This is important. Here you can see it. Number of rows 2 millions, estimated number of rows 1.3 millions. This is the new one. The old one has a much, I do not want to say much better, but a better estimation. That means the legacy plan, this is the legacy cardinality estimator, and the plan is much better. And that is a problem. The problem again is we can try to create a composite statistics with full scan on column 1 and column 2. But when I now execute the query again, the statistics are not getting better. So we can see it's still 1.3 million because we are in a disconjunction. So whenever you run into disconjunction, you really have problems. The only way to solve it is that you run your query store before you migrate. Migrate, but leave your database in the old compatibility level. In this case, 2012. Run it for 6 weeks. I don't know, whatever is represented for your workload, and then change your compatibility level to the new version, which is maybe 2019. And then you have to go to the query store, especially on the regression query. We should see, now I think we do not see it here anymore because sometimes it's not working, but I guess maybe in the top resource consumption, I should see it here. This is plan 1, this is plan 2. So this will give you an impression about what is the difference between 2 cardinality estimator or 2 versions. We can even compare them. I know that I'm running out of time. I just need 2 additional minutes. We can say compare plans. We can see the old plan is cardinality estimator estimation. They call it model version 70. The new one is 140. I guess this is SQL Server 2019 now. And you can see this is completely different. Now it is on you to decide which kind of query you have to run in maybe with the old legacy cardinality estimator, which works like this. We go here and say use option, use hint force legacy cardinality estimator. When I run it, it behaves like the old cardinality estimator, even the entire SQL Server is running in 2019. This is a selective hint for a few queries because the majority of the query will run better with the new cardinality estimator, but a few of them will run much, much worse. So this is why query store is so important for migration. Again, run your workload with after migration with the old compatibility level, monitor and capture all the queries in query store, do it for a while, change and compare. And think about disconjunction. The only way to solve it is with a hint. The conjunction is definitely something which can benefit from either composite statistic, because we can create a statistics on two columns which can be used in an AND, or maybe in a composite index, in this case, column 1 and column 2. That's it from my end. Any questions? No question.
All right, let me check if we have any questions here. And remember, if you're watching this presentation real time, enter your question in the live chat, and you need to you just subscribe, go to live chat, enter your question. If you're watching the presentation afterward, just use the comment section below the video to enter your question. So let me check here. I have a comment here from DG. Thank you, DG. And she enjoyed your presentation.
Thanks a lot.
But no question at this time.
Okay, that's fine. Maybe we can wait for another few seconds that we will have a chance to ask questions after the presentation. Otherwise, feel free to reach out to me if you have further questions with regard to query restore, or even performance tuning, or even for another presentation or whatever.
All right, and here, Torsten, I saw you did just finish, if I'm not mistaken, a coverage of the Cardinality Estimator. You talk about the also extensive about the query store and so many other options here that make it to optimize the code, identifying, and also identify when there are problems, which I think is cool.
Mm-hmm.
It's not, you not only cover how to do, but you also cover, hey, this is the challenge you may encounter when you're doing this.
Yep, true. I hope I did it.
Absolutely. Yeah, I don't see any other question this time, so I would like to thank you. Do you have any more parts to cover? You have reached an end here at this point, Torsten?
I reach a meaningful end. Yeah.
All right then. So let me switch over here. Yeah, your information is there. Oh, 1 second. All right, Torsten, we have reached here completion of this great presentation where we covered several techniques on optimization for SQL Server as well as Azure SQL DB that will improve the workloads. As I just said, we just cover using query store, Cardinality Estimator, and a series of other techniques that we all can use. And which, as you said, how can I say, it will improve because of, reduce the cost by the use less resources in the process. Would that be the case?
True, that's definitely the goal. And again, it is much easier in these times when you operate your SQL Server in Azure to reduce costs by having a proper performance tuning. Maybe even before you migrate or when you start your project in the cloud, make sure that you do it from time to time in order to reduce the overall resource consumption and again to downscale your instance to save money.
Very good. And the only thing I'd like to add to it is just people also remember to do a baseline, which is, the first
Yeah.
measurement you do out there. You can see that, so you can use that to future excuse me, estimates as you go through the process. Because one issue, remember, as time goes by, the vast majority of the time you'll get more data, and you can analyze how all those changes affect your processes and how can you make it better there.
That's a very good point. So I think the query store will definitely help you to have a baseline, yeah, because you can go back to the history. But you are definitely right. So the number of rows in modern systems, OLTP or data warehousing, it really doesn't matter, will definitely increase over time. That means when your SQL Server is running fast today, maybe in a week, it is not running fast anymore because you do not have the right index strategy in place or whatever the reason is. And that is something you need to take into consideration. You normally do not want to upscale because your query workload is getting slower because you do not solve the root cause. You just put on more resources on top of it. That will work for a while, but it will not scale.
Absolutely, absolutely. All right, great. Let me take a final check here on questions. We are all good here on the questions. So with that, I would like to thank you, Torsten, very much for making the time and being here with the user group, sharing the knowledge, some outstanding information here.
Thanks a lot. Thanks a lot for the invitation.
And I also like to thank all the attendees, whether you are watching us in real time as well as on the on-demand after the presentation. Remember, drop a comment, let us know if you have any questions. Also, let us know what you like the most in a presentation. And if you have any questions, you'll see Torsten's contact information displayed right now. And wish you all, and hang on just a second, Torsten. In the meantime, thank you all very much for following and attending the presentation. And have a great day out there, folks. Take care.